between the circle and graph. We have on shortest path, and there's many other kind of problem with graph theory. Graph theory is a big domain. People now move to like graph neural network. Somehow means they use graph for machine learning and AI. It's quite new and not easy. But say that we have a lot of work on graph, and we have database graph QL. No, sorry. Graph query language like Neo4j. It's in graph database. So we don't have time for everything, and we cannot for everything. So the best please, if you really want to do a bit of research on computer science, graph is the way to go. Okay, you can read a lot of new things, application of graph, any problem you can solve graph. Okay, and here we for this section, I will not try to give you new thing because it's the last day already. So we have I just introduced you some others like on pair, shortest path is another algorithm that have you to find the shortest path between all pair. It's been before we just have the one single shortest path, means we have one given source node and we try to find the path from that source node to everyone else that is reachable from the source. Now we have on pair shortest path, means they try to find all possible paths available for for the things. Okay, so we have it flow algorithms. Just have the algorithm is that this is just 3 for loop, and we do if the idea behind it is try to try on pair of like vertices that we can visit, and that the idea you can play it at home. Then there is a like a sample version of that is we are not only care about it's just not the shortest path, but we say whether or not we have a link between two nodes or not. So that could be a problem. We can use the on pair shortest path to find it, and then we say quite transitive closure. Okay, just checks whether or not we have the path from one place to another. Then we have another kind of like say application that is quite useful for the maximum flow. Means that assume that we have graph. We have graph. I don't know. I have an example here. Sorry. We have a graph, just like the network, the pi or water system. Okay, or you can think it just like the traffic in Ho Chi Minh City. We have the width of different streets as the maximum flow of a vehicle that can go through that street. And now we want to find the maximum flow that can curve flow of like a traffic vehicle or flow of something else or water that can go from one place to another without network. Means if I want to go from Ho Chi Minh City to like Cần Thơ, let's say, we will try to find all of the possible paths, and then what we say the maximum like amount of vehicles, cars, and motorbikes that can flow this network. What would be the maximum? Okay, so that algorithm will tell us. So we can estimate what would be the maximum capabilities of our system, of our traffic, of our network, of our like water system, whatever. Okay, that is very important. Then they will try to find use the have you to find the bottleneck. Where is the smallest like path, like smallest street that we stop everyone. So there is the moment, there is the location you should like extend if you want to improve the traffic throughput of your system or your network, your traffic, your network. Okay, so maximum flow is quite like useful information. And then we have, I think we have maximum flow mean cut, that is the proper one. And then we have another one that is the bi-party graph. Means we have two set of like male that want to like find let's say to marry to find a girlfriend, and then we try to match them with some given criteria and so on. So we have the bi-party graph and we have algorithm to match them. So you see that the graph can go for many other applications. So I strongly suggest you to spend time to work with graph theory in general. Okay. So otherwise, that is the thing I want to show you for like feature work of further reading on graph. Okay. And I think that's it for the graph section. And what I want to show you for last one is this one. Just I just want to show you this one, some slide on graph, but the key idea is just to summarize it in different way. So we have graph, just as a review, okay? So vertices and edges, or nodes and edges. We can have graph to represent a map, link a different place. We have adjacency, some definition. We have the path, okay? We have the connected graph, which link everyone together. We have the notion that unconnected means you can say two set of nodes that are totally separate from each other. We cannot go from one place to another. We have the directed graph. As we know, we have like a one-way street. We have from A to B, but not B to A. And that could be in the same time connected or unconnected. And we have notion of strongly connected later on. So we have the notion of weighted graph, means each part there we have the numbers to represent something that you can map to your real life application, like the weight, the distance, the size, the width, the height, whatever. Okay. And we have some way to implement it. In Java, we use a Jackson symmetric, a list of successors or whatever. Okay, and based on that, we can do on kind of like application for loop, while loop to show, to find, to do things. On top of that, we have application. Yeah, we have a way to do. We have the origin to explore the graph. We have the depth first check, algorithms. No, go different, go back, different, go back. We have it. Yeah, we have some explanation here. We have the application that's shown here. The idea is we can use like a stack to have you to manage the list of nodes to visit it. If you move from stack to queue, that you will have the DFS algorithm. Okay. Oh yeah, we have example here. We have complexity of that. We have preference check. Example complexities. We have minimum spanning tree. No? We have the way to link everyone together with the smallest number of edges. With a tree means we would have no cycle there. And if we have the weighted graph, so we have this sum of all of the selected node and selected edges must be a minimum. So we have minimum spanning tree. Okay. It. So we have the directed graph, we have just symmetrics, we have double sort order. Yeah, we can have this like pattern, and we try to find the way to do, the way to learn, so such a way that we satisfy all the constraints of our system. So we will start here. Okay, we have with the graph. Now this is the thing that I want to show you for this, just to prepare you for the final exam, is the way to represent some algorithms on the tabular format. Of course, it is easier to explain to do in real life, like real-time coding or demo. We based on the notation, annotation, the drawing on the top of the graph. But if you really want to say use the tabular format, that is the idea that you can start. So we have this algorithm. Let's say we have the step here. We have the number of nodes, like the mark node, and we start here. We have the all of the nodes on the top of the header here. Each column is for one node, and let's say from A here, if you can see it, A. Let's say start from N, from A, people will try to update the path from A to B, A to C, A to D. And you see that we update A, you use A to here, B, A to C, A to D, and E and F infinite. And based on this, okay, you can see that we can find the smallest number to start with. So it means we start from D. The next step, we start with D. So we have at D here at the selected node. And with D, we try to update everyone else. We update B, but nothing changed. We update C, give it a better distance from A to C. So we update here. We have the D to E. So we expand the value here. You see, and based on this row, you can select the smallest number to do next. Let's say, so we have E, we take E here, and we we update D, because E can go back to, E can go to C, so we have better path there. We have E go to F, we update here, and again we select the best one, so we have B, where we remove it, and we update C, we update and so on. Okay, so you see at least here is the way that have you to say show the graph or run these algorithms in the tabular format. And maybe in the final exam, if I ask you to do some algorithms, I will propose a tabular format so that you have to fill it with the corresponding value. Okay. Just I don't know if you really need to run the this algorithm again or not in class, just to practice. Otherwise, I think you can do it at home. Just use this tabular format to say here for you. Copy it here. You say, then you can use it later on if you want. It's been, instead of working directly in graph, we can do it at the table. Okay. We have some discussion on graph and so on. Okay. So otherwise, that is the only message I want to tell you for the this algorithm, the way to show the say the data. Okay. Yeah, and that's it for graph. So now I think time for revision. Okay, time to review or prepare for the final exam. The final exam start with the slide in the first section. We have what we have so far is here for okay for the midterm exam we finish here, no? So for the midterm, we already and stuff here. We have question related to array, to sort, to stack, to list, not to recursion, but including the part of that. Now for the final exam, the idea, the main content I want to check you is on this one. Okay, from advanced sorting, binary tree, hash table, Reup, and advanced Reup algorithms. Different algorithms we have so far, except for the whole pairs of this bus and maximum flow and the thing that I mentioned in this section. I will not say check you on that, but the others will be. Okay, the goal again to verify, to check your understanding, your skill on these algorithms. So just to review, so we start back here with the advanced sorting algorithms. So if you remember well, that will be the shell sort algorithm and the quick sort algorithms. No? So for the shell sorts, do you want me to open the slide again, or just this is enough for you to follow? Do you want to show the slide again, or that while listening you still can remember? Hello. Back to question of King. So of course, for the final exam, that it will be open, not it's open, not like the one that we have for midterm. It's mean you can bring as many handwritten notes as you want. Okay, it's mean you can bring your notebook, not the electronic notebooks, the notebook. They have your handwritten notes. That would be okay. Okay, so now for the final exam, I try to have question for all of these. So we have question on advanced sorting algorithms. It could be cell sort or quick sort. I show you. Normally that would be like running it manually. We have question on binary tree, okay, especially binary subtree. So we have the way to organize tree like this and like that. You need to know how to delete, how to add, how to build a tree, how to do shares, how to implement some function like find the max, find the min, share person, tree is from theory thing, and also putting you writing goals to find things for every to work with the binary tree better. It's easier for you. Otherwise, that things, so we need to work on the binary tree. Okay. For the hash table, you should remember what is it, how to like define what is meant by hash function, how to what is the relationship between the hash function and the size of the table, or the hash table. Okay, and then you have the another thing like how to solve for collision in hash table. Okay, the message you should remember is hash table is good for searching or locating something. It could be in no one, but if we organize it into hash table, use the array, it takes time to say to solve the collision problem. Means the situation when we have multiple items that hash into a same index. Okay, to same index, and then we have to solve it. It could be open addressings in we step by step move it, or it could be like separate chaining. It's mean we have linked list to store it. So you have to remember that, and you should be able to build a hash table. And you should remember that for the hash table, we if we want to resize, if we want to make the hash table bigger, what should we do? Of course, it must be something that we have to create a new array and insert every single item from the old one to the new one, because we change the size of the hash table and the hash function will change. Okay, so we have hash table, and I think that's it for hash table. And then we have the Reup, different algorithm Reup, and I will ask you to work a bit on Reup theory. Okay, at least you should know how to run all of the basic things like the DFS for sure. You should know how to check for strongly connected component. We should be able to, no, before that, we should be able to work with the different way to present the graph in memory. We have adjacency metric, we have incident metrics, we have list of successors. That is a way to present graph in memory, and that will help you to work with graph. Then later on, we have notion of decree, in decree, out decree. We have the then DFS, and application of that will be finding the shortest bar, finding topological sort order, finding a strongly connected component, finding loop, it's been a sub a package, or during single socks, short split bar algorithms, and you for short this path algorithm, you must know that in which condition we should use Bearman, in which condition we should use that this algorithm. The key thing will be we cannot play with absorbing circuit. Absorbent circuit, we have problems because it will make it smaller and smaller every time we take it. And it is a circle, so we do it as many times as we want, and we get a smaller number every time. So go that way, that will be the thing that we cannot have a shortest bus or the system for our Reup. Okay, and this algorithm try to avoid that by saying no to any Reup with negative values. No? Without negative, we don't care about circle anymore. It could be any circle, but anyway, and with positive, we don't care. For Bellman, so the approach will different. Say, well, I will not work with circle. For Bellman, say no to circle, and you can have many negative value as you want. Okay, so we have it. Yeah, that is shortest bar algorithms, and we have another basic one would be to find the minimum spanning tree. The idea is, for example, just text add edges one by one to make sure that every time you text some edge, that must be must not form any circle with the selected edge. And we have the way to verify or to check the circle. Of course, we can run the DFS algorithm again, or we can read numbers on the connected nodes to detect the situation, the package is been a link easier with the number labeling like that. Or we have the prim algorithms by saying that we build a minimum spanning tree by using a mark set, a set of selected nodes, and every time we take an edge, it must be some edge that go out of that selected set. And if we go out, we make sure that we will have no circle at all, because every time we go out, we will not come back to our selected items. And then every time we go out, we check the minimum or the means value and so on. Okay, and that's it. I think that's enough for our final exam. The final exam could be like 2 hours, but I think that's just. But that if it's 2 hours, would be something. The structure is almost like the previous one. We have 4 to 5 questions, and that's it. Okay. Yeah. Everyone, I think that yeah, it's good. Yeah, I don't have the final exam yet, you know. Yeah, we have the schedule, but the structure of the exam is not decided yet. Yeah, the day fixed. Yeah, is I think you got it. The date for the final exam, I think 1 month from now, so almost 1 month from now, 3 weeks from now. Yeah. I will check the final exam. Say for the structure and algorithm, that will be it's 23 of June. Okay. Yeah. It will be. Yeah, it is. The exam is like 22 hours long. Sure. 23 is sure. Okay, everyone. Otherwise, I think that is enough for this because uh, next week you have the projects now. Try to do more projects and to make the class, and that's it. Okay, everyone. Do you have any other thing that you want to discuss? You want to ask me for the DSA course? Again, what I would say is DSA course is the basic one, but for almost any kind of like interview, people do have one question on this kind of topic. Okay. Data structure algorithms, because you know, as the developer in programming and things, technology will change like every year, but the basic algorithms, the complexity, the graph theory, something like the one that is like that. People need to use it later on to solve some specific problem. Means you have mobile application, you have web application, whatever. But we need to have algorithms to solve a specific problem from our customer side, because the web is not only just to show the data, but you have to process the data some way. Okay, and with the good like a mindset on data structure and complexity of the algorithms and so on, you be able to make a decision on what kind of data structure you should use, or what kind of algorithm you should use, what the complexity of that. Because if you have technology with you, you can ask like why and how it can be better than the others. What is the data structure behind it? So either way to go and way to work means if you want to improve the performance of the system, please go check the document of the implementation of the system, how they implement like the sorting algorithms, how they implement the scaling, how they implement some way of doing things. So with that information, you can make better decision on which kind of technologies or tool or form function you should use to solve the problem, especially to optimize a problem. Okay, and this course will have you to say to move forward if you want to go for master and PhD, especially PhD if you work with say scientific thing. The book like introduction to computing will be your friend. Do you remember this one? Introduction. Introduction to algorithm. Sorry. We have the new. We have the new one. This one. We see the. We see the book. Hard to find that. I think we have it in our school or not in our library. I think there's a new one. Yeah, we have a new version of that. See, just published this year. So anyway, introduction to algorithms is the best book on this one. Of course, we have many others one that are easier to read, but this one is the important one. You should read it. There's many complex problems which you want to go deeper on that. Okay, everyone. Otherwise, now your turn. Question and things, everyone. I have a question. Okay. Question like, you mean if you want to go through all of the value in hash table, they think like that. Hash table. This is an array. If you are the one that implement the hash table, it means you implement it, or the library, the Java library, allow you to access to the key. That would be very easy. Just make a for loop. So like in Java, we have hash map. They manage actually the set of keys separately, so you can always get function like get keys. So they will get all of the value, or if you want to get all of the values, that would be easy. Okay. And for hash table, easy array. How about making a hash table using array? Yeah. Hash table using array. What is the problem? You can always just go through everything. Make a for loop with the array and get out on the data then. Does it array? Yeah. Just while waiting for your question, like the next thing is there's one other direction that you really say love science. You spend time to work with complexity, how to analyze how to analyze the complexity of a given problem, of a given algorithm is always not easy. Okay, so we have basic algorithms. Yeah, it is quite straightforward, but there's many like different things on complexities. We have the notion of P versus NP. That would be another. With the hash table, we have the keys. So the things when we need to iterate through the hash table. Yeah, it could be the yeah, people just someone insert the data to the hash table, not you, or you insert it somewhere, but you did not manage keys, and then you need to iterate through all of the keys. Yeah, it's just a normal task. Okay. When you use hash table as storage, then people give you a hash table. Yeah, to move it. Yeah, to double the size or increase the size of hash table. Yeah, could be a problem. Or just giving a graph in a hash table or hash map. You want to make sure to check how many items you have. Assignment score for the lab, you mean? Or the final exam? Yeah, yeah, we have on of your score 2 weeks after the final exam. The projects. Yeah. Of course, when you move it, you have to rehash, but NAS like he need to go through all the elements to rehash. He don't know the element at the beginning. Okay. Everyone else question? Anything related to sorting, queue, stack, list, recursion, everything you want to ask. Okay. Yeah, Khang, of course, we need to iterate, okay? Because how can we know which number should we insert to the next one, to the new one? Everyone else, any other question for this section? No? Hello. Time to ask me something. No? Nice. So, okay. Now maybe just a few questions for me. Okay. So for this course, what okay, what you can propose, what is your comments to improve this course? It's been how to say yeah, it's just my question. Like, do you have any any suggestion for me to like improve this course? Say, giving you more exercise, working on a specific topic, special data structure that you want to suggest, or like any other things. Okay, focus more on the complexity part, any other thing like that. So please let me know. Okay. For draft parts, I do want you to play a bit with the coding. Maybe just basic one, but we I intend to give some question on coding. You don't want to play with the project. The project is kind of a thing that you need to project is a thing that you need to sorry. Project is something that you 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 need to play, you need to work with your friends. Yeah. Okay, and others, give me some comment, please. Okay. Okay, okay. Uh, others, anything else want to comment? Uh, okay, it's been got more on the tree and the graph, no? Yeah, at least we have the lab for the graph section. Hope that I give you some concrete idea on how to, yeah, how to code for a graph or and how to store it in database in the memory. Yeah, yeah, I noted. Maybe we need some more code for no for the tree. Yeah, we do have some some exercise in class on finding uh, an item in variation tree. No, like okay, yeah, yeah, I can give more exercise for the putting in graph. Yeah. Okay, thank you. Three. Okay. Okay. Everyone now they think that I want say for the remaining part of this section. Uh, I so give me some more suggestion and comment. But otherwise I really want you to play a bit more like one last time with this one is with the on we don't have lab on human coding, but it's kind of a mini project for human coding. So I want you to say with that. Mention human coding somewhere in the lab, in the mention about human coding is in the tree, is where people organize the data in special ways so that we can compress the item. Okay, so now I really want you to play a bit with human coding. Okay, for the projects, yeah. Yeah, I did mention much on the projects. Yeah. Yeah, sure. Yeah. Yeah, what I can say. Yeah. Yeah, because yeah, it I think okay. I put it in the somehow in the but in the I put it in the lab, so I don't mention the projects. Well, for yeah, different kind of projects, but projects you need to, if you play with uh, say lies or sheep, battleship, that would be algorithm to share and the not the mine, mine sweeper. I don't know, I don't know your project topic, but my sweeper is just basic application of like manage array and run some like exploring algorithm on array. It's somehow like a graph, but just a dash graph, everything with array. This is just the algorithm to say explore the component to find whether or not it reached the border. Yeah. Uh, yeah, I think I can spend time to can apply different algorithms to explore the graph or the map in my script. Yeah, the algorithm is quite basic. Just checks whether or not for each position we have 8 slot now. If 8 of them can be cross some way, we go that direction. Yeah, I think it's show mention about talk. Give some question for the for the um, for the for the projects. Okay. Uh, Here there is last time I we don't have time for human coding in the lab, but for the remaining part of this section, do you want to just learn a bit more on this? It's just a very concrete example of how to use tree to build things and how to play with say application of the tree on how to compress the data. Uh, so that is the goal. So I say now I say it, I think like you better take like a 20-minute break or so for your lunch, and then back with this say exercise on human coding. Okay. And we will have we open for discussion. It's been time to everyone to sit down, read, and say human coding. Okay. So that's the thing. Not before last year I put it at the lab, but now I replace it with the Reup. I think Reup is yeah, better. Okay, but now here's the document. No, it's not a final exam. The final exam is say the shortest with 5 questions or so. You don't have to spend time to work with Human coding. It quite complex for final exam. Take a bit more time. But anyway, now I suggest to take 20-minute break, okay? And then back with human coding or reading and doing exercise on that. That will be an exercise on trees and things, okay? Okay, everyone, I see you in 20 minutes, okay? And would you spend time to read? Okay, spend it, or just work with you. Okay, everyone, and see you in 20 minutes, okay? Hello. Are you back here? So I will have question for you, but after a few minutes. But do you want to like have breakout room so that we can discuss with each other, so we can read together to answer my question? Hello. Uh, yeah. I really want you to at least do with this one. Okay. This one raw human coding tree for following text. Okay. Your names and working on DSA lab. Okay. So that will be the task I want you to do. For the breakout room, so let's say I will create a room randomly. Okay, just try to start to work with your friends. Mhm. Okay, let it be random. So task. Minh and Thông, why you? There's no one in your room. Uh, yeah, tấn tài sự phụ đi chọn cho rừng. Okay. You have your room? Yeah, John. Mm. I as I create breakout room so that everyone can work on Huffman coding together. So the task is to explain how you can compress data with Huffman coding, and the second task will be build a Huffman coding tree for your text. Okay. So you have your breakout room. Do you have your uh, you don't have your breakout room? I try to find. You want to join the room with I say I will set you to the room with Minh, okay? Okay, hello everyone. So so you see that now I have I ask you like you to read and work on an application of three, okay? And then finally we have to draw something. So you see that this exercise is just say a way to just to people use free written queue to do something useful. And as you as a reader or a student, when you learn how to do it, you see you can do it after like a half hour of reading, okay, or more than that. But the message is that um, uh, data structure and algorithms is like that. We have many problems, we have many things to do, and we'll have to come up with a solution, say to compress data to do things. And your task is your to do thing later on will be try to read as many as like articles, data structures, and things like that, so that you're aware that there exists such a thing to help you to solve the problem at hand. Okay, in your community. So, okay, again, Introduction to Algorithms is a good book to start with. And I think that that's it for this course. And this last exercise, I could consider some similar format for final exam. Means I try to give you something that is a bit easier, but that is what you may have in the final exam. I gave you one description of something, some data structure, and ask you to manually implement it. So, okay. Okay, so I think that's it for the review, and that is the last section for the data structure and algorithms. And I think for you, you have it in the following course. We may have a database, web application, and many other things, but not a lot on data structure and algorithms like this anymore. So it's your turn to read, to prepare for your career later. Okay. Otherwise, that's for this course. That's it for today. Thank you, everyone. I hope that I can see you in person, like somewhere in school later. Okay. Yep. That's it. Enjoy your programming journey, and goodbye. Good luck for final exam. Bye bye. Thank you, everyone. Yeah. Really? Okay. 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 Yeah. Okay. Yeah. See. Have to see you again soon. Bye bye. If you have any suggestion, propose, comments, for me, you can directly message me in Teams. I'm almost on the way there. It's at least the team will tell me. Okay. Otherwise, goodbye. Bye bye. Thank you for joining class and acting. Be active in class. Thank you. Bye bye.